Okay, we're going to apply triangle sum properties as part of section 4.1. We have two essential questions to try to answer. How are triangles classified, including side lengths and angle measurements? And how are the measures of the angles of a triangle determined? Let's get started with an example on classifying the triangle by side length. The slashes tell us all three sides are equal. So what do we call a triangle with all three sides being equal? Equilateral. Notice in these answer choices, we actually, if we're talking specifically about side length, then these three are options. These are length, side length descriptions. Acute, obtuse, and right are angle descriptions of the angle. So just keep that in mind when we're classifying triangles. Now let's talk about angle measurement of the triangle given. Now we're going to have to assume here just for a second that this angle is in fact the way that it appears, which it appears to be an obtuse angle. So that gives us our answer that this triangle is an obtuse triangle. What's the measure of each angle of equiangular? So you've got a triangle where all three angles are equal. That's a 60-degree angle in that triangle. Is it possible for a triangle to be obtuse and right? Well, obtuse means the angle is greater than 90 degrees. Right means the angle measurement of the angle equals 90 degrees. Well, in a triangle, all three angles add up to 180 degrees. Well, if one angle is greater than 90 and one angle is 90, you've already added two of the angles up to be greater than 180. Therefore, it's impossible to have an obtuse and a right triangle. How about obtuse and isosceles? Actually, we saw that in a previous slide. We saw an example of an obtuse triangle that was isosceles. All we really need to do is take a line segment and take a line segment congruent to it and make them come together to form an angle that's obtuse. And then clearly, if we connect them, we have congruent sides here making the triangle isosceles, and we have an angle here greater than 90 making it obtuse. So yeah, we can do that. How about obtuse and equilateral? Can all three sides be the same and have an obtuse angle? That's definitely false. The only triangle that can be equilateral has to also be equiangular. And we've seen in a previous slide that that means each angle measurement has to equal 60 degrees. All three of them do. Definitely not obtuse. Okay, the angles of a triangle are in the ratio 3 to 4 to 5. Find the measures of the largest angle. Okay, so the ratio 3 to 4 to 5. So if we think about one angle being 3 times x, another angle being 4 times x, and the largest angle being 5 times x, all three angles should add up to 180 degrees. And you can see this 3 to 4 to 5 ratio is preserved with this 3x, 4x, and 5x. If we add these together, 12x equals 180, which means x is equal to 15. If x is equal to 15, then the largest angle, 5x, right here, must be 5 times 15. Final answer is 75. Okay, let's see if we can't get angle A. Here's angle A. And all angles are given as an algebraic expression. So let's do what we know about triangles, the measurement of angle A plus the measurement of angle B plus the measurement of angle C should equal what? They add up to 180 degrees. So this is going to be 10x minus 6 plus 7x plus 6 plus 8x plus 5 is going to add up to 180. We combine like terms, looks like 25x. This negative 6 and plus 6 cancel out, so plus 5 equals 180. 25x equals 175. X is equal to 7. So the measurement of angle A now is 10 times 7 minus 6. Final answer A. Okay, let's find the measurement of angle BEC. This angle right here is what we're shooting for. And we know that BE bisects ABC, and that CE bisects ACB. So we know this angle is congruent to this angle by the definition of an angle bisector. Oh, come on, there it is. And we know that this angle, so 3 stripes, try that again, 3 stripes, that's congruent to this angle, again by the definition of bisectors. So one way to think through this is to say, since these angles are congruent here, maybe we'll call this the unknown angle X, and this is congruent, so it has the same measurement, unknown measurement Y. Over here we can call this, these two, the first ones have angle measurements X. Now angle ACB is cut in half and bisected, so we'll call ACE measurement Y, and we'll also say ECB has a measurement of Y, because again those angles are bisected. Okay, so what that means is the 80-degree angle CAB, plus the 2 X angles added together plus the 2 Y angles added together equals 180 degrees. So that's looking at this 80-degree angle, these 2 X's, and these 2 Y's. So it's looking at this big triangle ABC. So this is triangle ABC. Right? What this does is, if we subtract the 80, gets us 100. If we divide by 2, what that gets us is x plus y is equal to 50. Well, if we focus our attention now on, let's see, if we focus our attention on triangle EBC, so here's triangle EBC, we don't know the measurement of angle BEC. That's what we're trying to find. But if we included in that angle, in that triangle, is an X and a Y, if we add those together, we get 180. Well, we actually just solved right here for what X plus Y is. So this actually is the measurement of angle BEC, which we don't know. Plus, here's x plus y is 50. Okay, so now we can subtract 50 and we've got our final answer. It's a 130-degree angle.